What happens when your AI tools encounter errors? Should clients see the full details or just a generic message? We'll implement a division tool that demonstrates FastMCP's error handling system, showing exactly how ToolError differs from standard Python exceptions. You'll see how to configure which error messages propagate to clients while maintaining security, with ToolError messages always visible regardless of the server's mask error details setting. From FastMCP, import FastMCP. From FastMCP exceptions, import ToolError. At MCP, tool. Def divide A float B, float, float. Divided by B. If B equals 0. Hash error messages from ToolError are always sent to clients. Hash regardless of mask error details setting. Raise ToolError. Division by 0 is not allowed. Hash if mask error details equals true. This message would be masked. If not is instance, A int float, or not is instance B int float. Raise type error. Both arguments must be numbers. Return a /b. This demonstrates FastMCP's component pattern, where the @MCP tool, Decorator, transforms Python functions into AI callable components with built-in validation and controlled error handling. The Decorator creates a clean separation between implementation logic and AI interface concerns, using Python's native type hints and docstrings to define the component contract. What distinguishes this approach is how it maintains standard Python development patterns while adding AI-specific capabilities like automatic schema generation and error translation. The pattern establishes a predictable execution flow where type annotations define the input contract, and exceptions follow explicit propagation rules. ToolError exceptions always send their messages to clients regardless of server settings, while standard exceptions respect the mask error details configurations set during FastMCP instance creation. This creates a two-tier error system: framework-specific errors that always propagate, and implementation errors that follow server-wide masking policies. The same principles apply consistently across all component types in FastMCP, with each having its own dedicated error class. This component-based design solves the challenge of safely exposing backend functionality to AI systems without manual API development. The minimal overhead of adding type hints and a decorator provides full AI integration with proper validation, error handling, and schema generation. It's particularly effective for building AI assistants that need to perform deterministic operations beyond the model's training data, with the same patterns working identically for both synchronous and asynchronous implementations. Let's break it down. From FastMCP, import FastMCP. From FastMCP exceptions, import ToolError. Imports FastMCP for creating AI callable components and ToolError for tool-specific error handling. The ToolError exception ensures its messages always propagate to clients, bypassing the server's mask error details setting, while standard exceptions like type error respect masking when enabled. This pattern applies consistently across all FastMCP component types, with each having its own dedicated exception class that defeats error masking. At MCP, tool. Def divide A float B, float, float. Divided by B. The @MCP tool decorator marks this function as an AI callable component in FastMCP. It automatically generates the tool's schema from type hints and docstring, creating a strict interface contract between Python and AI systems. ToolError exceptions always propagate to clients regardless of the server's mask error details setting, ensuring critical validation failures are never hidden. This pattern applies consistently to all component types, with each using its own error class that bypasses masking. If B equals 0. Raise ToolError. Division by 0 is not allowed. This validation enforces division safety by raising ToolError, FastMCP's component-specific exception type that always propagates to clients. Unlike standard Python exceptions like type error in the subsequent check, ToolError bypasses the server's mask error details setting configured during FastMCP instance creation. This pattern ensures AI callers receive explicit error details for invalid inputs while maintaining consistent behavior across all FastMCP component types.
Hash if mask error details equals true. This message would be masked. If not isInstance, A int float, or not isInstance B int float. Raise type error. Both arguments must be numbers.
This performs runtime type checking to ensure both inputs are numeric before division. Unlike ToolError, which always exposes its message to clients, this type error respects the server's mask error details setting configured during FastMCP initialization. The pattern is standard across all FastMCP components, with each component type having its own unmaskable exception class: ToolError for tools, resource error for resources, etc.
Return a /B.
Performs the actual division after validation confirms safe execution. This line represents the successful path where the tool fulfills its contract by returning the computed result to the calling AI model. All preceding checks ensure this operation only executes with valid numeric inputs, maintaining the tool's reliability guarantee. FastMCP tool validation. The @MCP tool Decorator transforms Python functions into AI callable components, where ToolError explicitly defines contract violations that always propagate to clients regardless of server masking settings. Standard exceptions like type error respect the server's mask error details configuration, creating a deliberate separation between interface requirements and implementation constraints. Structure validation checks from most specific business rules to most general type safety to maintain clean error hierarchies.
The tool that enforces nothing accepts everything, yet answers to no one.